I am coming to you from the Kansas State University Olathe campus. Just recently, I have joined the faculty. I've been in industry about 25-ish years prior to doing that, but have gotten all three of my degrees from Kansas State University in industrial engineering. So we're very excited to have the opportunity to have a presence here in Olathe and wanted to get the word out for those that may want to join some of our programs. I'd also like to introduce our department head and professor, Dr. Brad Kramer. He is joining us from the Manhattan campus, and I'll let him give a little background about himself as well.
Morning. Yeah, as Dee Dee said, my name's Brad Kramer. I'm the department head of Industrial Manufacturing Systems Engineering. I've been part of this department. In fact, I got all three of my degrees, so I know the program well and excited to be chatting with you today about potentially joining one of our graduate programs.
Okay. All right, just a little bit on format. The way that we've set this up is that we'd appreciate if you could type in any chat questions, any questions you have on chat. And feel free, as we're walking through this, if there is an area in particular that you'd like us to stop, spend some more time on, jump in. We're happy to stop and talk about it and give you any more information that you may need otherwise. At the end of the presentation, we also have contact information, so please feel free to reach out to Dr. Kramer or myself if you've got any other questions. If you'd like to schedule a visit here in Olathe or on the Manhattan campus, we're very happy to accommodate and give you the information that can help you make a good decision for programs for graduate degrees. So let's go ahead and get started. Now, this webinar we will also post on the K-State Olathe website after we're done. So if there are other things that you'd like to go back through, feel free, as well as reaching out to us. So I'm going to have Dr. Kramer go ahead and talk through some information about our program from an overall perspective. So take it away, Dr. Kramer.
Okay, thanks. I'm not exactly sure who all we have in our audience, so let me just start by telling where industrial manufacturing systems engineering fits in the whole scheme of life. We are the engineers that are concerned with improving the production, and we don't really care whether we're producing goods or services. We could be producing GPS devices or airplanes or computer monitors or Tony's Pizza. You know, it really doesn't matter if it's a good or it's services like healthcare or finance or transportation or distribution. We are trying to provide that good or service at the highest possible quality, the lowest cost, as quick as possible, as flexible and robust as you can, safe for the worker, safe for the environment. And everything that we do in our program is about trying to improve that productivity. So you'll see that in the graduate programs that Dee Dee talks about here in just a few minutes, that some of the things that we'll be talking about are very quantitative. We're concerned about being able to develop mathematical models and other analytical models and be able to optimize and help to make decisions. We also take our programs and deliver things that will help you to be better as an engineering manager or technical manager. How do you manage technical people and technical projects? So if you kind of put in the context that what we're concerned about is improving productivity, then I think all the degree programs that she'll be talking about in just a few minutes will make sense. Now, one of the things that we wanted to do up front is just kind of introduce you to our department here at Kansas State University. So we have this group of faculty that you see here. There's about 10 of us right now. We're trying to recruit another one to join us in this next year. And we span the issues of advanced manufacturing. We have several faculty there who are specifically engaged in how do you develop or how do you produce advanced level products using current and merging kinds of materials and being able to process them efficiently. So we'll do work with very fast pulse lasers, or machining using ultrasonics, or additive manufacturing. So we have a group of faculty that are engaged in that. We have a group of faculty that are engaged in more of the general industrial engineering, the quality engineering, supply chain, ergonomics kinds of issues as well. And then a group of faculty that are more engaged in operations research, and that's using basically the mathematical models to help describe a current system so that then you can understand it better, and then you can try to model it and optimize it, and ultimately trying to help people make better, more rational decisions. If you'll go back just the one slide to the description of the department, I'd just say that we are an academic program that has about 250 undergraduate students. About a third of those are women. We have, I guess, the companies that recruit our graduates most, particularly at the undergraduate level, have been Deloitte Consulting, Cerner, ExxonMobil, J.B. Hunt, Lockheed Martin, and PepsiCo Frito-Lay. Those are the companies that have come to campus typically to recruit. Most of our master's students that are at a distance from campus are typically working for a company, and they're not really looking for a new position. So it's difficult to really capture what the average starting salary of folks who choose to come, who just continue to work and then get their master's degree, because they typically get a bump in salary along the way, but a lot of times they're already starting above what we show here. So the data that you see here for average starting salaries, it's probably a little bit understated, I think, for those that are just continuing on with their company. So, whether you're working directly at K-State Olathe or taking courses at a distance, I think that the placement rate is extremely high for our graduates, both for those that finish a bachelor's degree as well as those that finish a master's degree with us. Our faculty is very much connected into research. We publish on average 3 journal articles per year, and an additional 2 papers and refereed conference proceedings each year, which is a very high productivity compared to the national average. That would probably put us in the top 10 or 15 programs in the nation, and that's on top of having a fairly heavy teaching load. We are engaged with industry in conducting joint engineering projects, research projects, and regardless of whether or not a student is engaged from a company in taking graduate courses, we are always looking for potential partners to work on joint research projects. And those projects can be things where you come to the university and actually do a project just using students for a project in a graduate course, for instance. But it also goes to the point where you have some need for some confidentiality and want to work directly with a faculty with expertise in the area you need. And so when you look at our efforts there in Olathe, think both of the educational programs that we're talking about here today, but also the opportunity to engage with faculty and graduate students in conducting research projects. And although we'd really love to have you in as a graduate student in one of our programs, we want to make sure you know that Dee Dee's there and I'm here to be able to try and respond to your particular needs in industry beyond just the educational programs that she'll be talking about today. So with that, Dee Dee, I'll turn it back over to you, and I'll be here listening, but I'll be on mute and be glad to jump in if you have questions.
Okay, great. All right, so why pursue an industrial engineering master's degree? This is an area that I'm really fairly passionate about. I have seen the benefits of having an advanced degree in my work in industry. a master's in industrial engineering, and the various options all kind of provide you a framework to be able to better analyze and make decisions that come up in your business. With that, one of the things that I think is neat about the field of industrial engineering is that it's kind of domain independent. And what I mean by that is that it applies across all size firms and across all different types of industries. So we focus on reducing costs, improving efficiencies, managing the supply chain, and really take that analytical view, how can we do something better? The courses that you'll take in this vein of graduate program or these types of degrees will help you with that thought process and provide you with the tools to really be able to impact your company, look at things differently, provide that added value to your company through these tools and techniques. Growing employment, industrial engineers typically have no problem finding jobs. Our starting salaries are good. Just a lot of great aspects around the graduate program and the program from an overall perspective. So, as Brad mentioned, we have a number of different areas of concentration. Here, we talked about advanced manufacturing. We've got a number of faculty that do that. We've got a very strong operations research capability, and we'll talk a little bit more about what that involves. Ergonomics, it's work design, it's user experience design, those types of things. So, as you get in, even high-tech firms, very interested in what that user interface is and how palatable it is with the users. Health systems, another great area for industrial engineering. How do you improve how a facility runs? Looking at inventory levels, looking at scheduling in terms of, let's say, emergency rooms or surgery, those types of things. And then some other, uncertainty and intelligent reasoning. So here's some decision-making skills that you can gain in looking at difficult problems and looking at ways that you can solve that. Quality engineering, talked about that. That's always a hot topic. And improving quality is a huge benefit to your company. And then the field of decision science, where putting structure around how you make decisions within an organization, having it logical, having it defined, having those decisions meet the goals and objectives of an organization. And there are numbers of methods that are available to use. As an aside, I'll jump in here. I am teaching a class, a graduate class, called Multiple Criteria Decision Making here at Olathe in the spring. And what we'll talk about are methods around decisions that involve ranking and resource allocation. So how can we structure those problems? What kind of methods can we use to have a very quantifiable basis for a decision? So there's information available out on the Olathe website about that, as well as in Manhattan. Advanced manufacturing, we talked about that. Now, the advanced manufacturing vein in industrial engineering is handled in Manhattan. So if you have a real affinity for that, it would be something that you would need to go to the Manhattan campus to do. Now, depending on where you are in your career, it may be something that you do want to do. So just wanted to make sure that you're aware that that's an option within the industrial engineering course of study. Operations research. So here, as we talked about, as Brad mentioned before, this involves more of the mathematical, statistical modeling around very complicated problems. If you've got an affinity for theory and have got, an interest in the heavier mathematical types of solutions, it's a great way, it's a great area to pursue. Interestingly enough, operations research, again, is used across all different types of industries in a variety of different veins. So very transferable types of skills that you find with operations research. Here, we talk about systems optimization and engineering. Really what we're looking at in industrial engineering is how we do it better, faster, cheaper, smarter. And so as we look at industry today, it's complex. There are multiple facets, multiple stakeholders, multiple types of decisions. So how do we model that environment and then provide value to our corporation in terms of enhancing their operational capability? So again, lots of different fields, a little bit different focus in that we're looking at that throughput view in a sense, and that entire supply chain and how that operates in terms of the complex operating environment that we're in today. So, options. We've got a Master's of Industrial Engineering. It is an on-campus and a distance. We are in the process of getting an additional approval to allow that entire program to be distance, so that is an option. We've got a Master's of Operations Research, which is also on campus and distance education. And then we've got a Master's of Engineering Management. I'll talk a little bit more about each of these as we go a little farther. Then, of course, we've got our PhD. Again, you know, for me, I went back for my PhD when I was 42. So you can go back at any point in your career if you've got resources, ability, if you need a change to do that. And after having been in business, going back and getting the academic degree really provided some meat in terms of that application of the concepts that you learn with an advanced degree. You know, one of the things that I spent the last 10 years at Sprint, just started here in October at K-State Olathe, and yes, I've made it through all of the different introductions, but I was thrilled to have this opportunity to come into academia full time. But one of the things that I believe my PhD helped me with was the fact that I was able to file and receive 12 business process patents. A lot of that is taking theory and applying it in a holistic perspective and generating innovative solutions to be able to do things. So don't rule out a PhD if you're at a point that it might be something that you're interested in, because I think that there's a lot of value in it. So, Masters of Science in Industrial Engineering. This is our fundamental core. What this master's does is builds on many of the concepts that individuals may have taken as an undergrad in industrial engineering, but can be done even if you don't have that bachelor's in industrial engineering. Really, we're looking at man, material, and machine. And how do we optimize those processes? How do we make them better? How do we solve complex business problems? So this degree is really kind of the heart and an extension off of the bachelor's in industrial engineering. So just as a note, I've seen many people successfully complete this even though they don't have the bachelor's in industrial engineering. So don't let that dissuade you in any way in regards to pursuing any of these degrees. Just wanted to flip up some of the core courses. There are a lot of options. So as you can see, we've got listed 3 core courses. Well, you've got, if you're going to do so 2 options in most programs in regards to completing a master's. One is total coursework, the other is coursework plus a thesis. So here, lots of different options, different areas you may want to pursue if you go ahead and do the Master's in Industrial Engineering. Masters of Operations Research. As we mentioned before, much more mathematically focused, analytical, using mathematical programming, statistics, probability theory, computer science, simulation, those types of activities. So here you're going to get a lot more into the math aspect with a Master's of Science in Operations Research. We have a robust program that many of the military take coming through our program because they are looking at complex problems, complex simulations, those types of things. So again, you're going to get a little more mathematically focused with this degree. Core courses here, as you can see, 2 in each of the various areas. We've got continuous optimization, discrete optimization, and stochastic processes. So some selections within those categories, and then, you know, for those total 30 total graduate credit hours, there are a number of other options and electives that you can select. Next, Masters of Engineering Management. This program is focused on teaching students how to manage engineering or technical organizations. Go through a number of the basics in terms of how we optimize processes, save costs, those types of things, and is delivered fully distance, so very much geared towards the working professional. Here, core courses with the Masters of Engineering Management. You can see Advanced Industrial Management, Engineering Project Management, Logistics, Production and Inventory Control, and Advanced Engineering Economy. So, that type of course, an engineering economy course, teaches you how to evaluate various projects using things like the time value of money, incorporating all of the aspects of costs when you model what an actual project is going to take to complete. So a lot of good coursework in the engineering management degree as well. So then, Doctor of Philosophy, PhD, as I said before, I think it's a great option at any point in your career. If you have an opportunity, I'm thrilled to be able to do it. But that program, you're going to be very research-centric. You will complete a dissertation, which in essence is a book, almost, in terms of what you're pulling together, but very interesting. Lots of opportunities with a PhD as well. You can go into academics, you can stay in industry, a lot of different aspects with that. So I just want to, continue to actually promote that as well, because I have found a lot of value in it. So admissions. Okay, basically we're looking for this program some type of engineering, mathematics, statistics, scientific type background with a strong background in applied mathematics. You need to have had some calculus-based probability statistics courses. And then there are certain courses that you can supplement. If you haven't had maybe some of the prereqs, there are maybe a few that you might need to take, and that's available as well. So undergraduate GPA of 3.0 or above for the last 60 hours of your courses. GRE is required, and then for an international student, you're going to need to ensure that you've got the language covered, the English language requirements covered for admissions. So admissions process. There's an online application. You've got an application fee. You need to provide your transcripts, your GRE scores, statement of objectives, letters of recommendation. There are deadlines for the program. However, we can admit into the program initially as a non-degree seeking and then have you fill out that application. So you're not stopped if you're interested and would like to go ahead and pursue this for the spring. Brad, can you correct me if I'm incorrect on that?
I think you're right.
Okay. All right, good. Don't want to lead you all astray. International applicants, same thing for a domestic applicant. However, need an affidavit of financial support and your TOEFL scores. Again, ensuring that you meet the language requirements to be able to take the courses. Okay, and lastly, contact information. Manhattan IMSE department, Brad Kramer, Dr. Kramer. You can email him directly and talk more with him about the programs. Same with me. Both of our emails, both of our phones are listed here. Do feel free to reach out to us if you have other questions about this. The actual admissions process is handled in Manhattan. So just so you would be aware, however, there will be course offerings here at Olathe that you would be able to take from a face-to-face perspective sitting in classrooms here. So do we have any questions? Okay, what are we looking for with the statement of objectives? Here, we'd like to understand what you're trying to accomplish in regards to pursuing the degree. That helps us match you up with professors that you may want to work with, courses of study, electives, those types of things. So it provides us some information in regards to what you're looking to do, what you would like to get out of this program.
Yeah, I'd add to that, Dee Dee, that it's really not a screening tool. It's more of a tool for us to know you as you apply for the program and be able to advise you well. It is important to us to understand what your purposes are in getting the degree so that we can help you meet your objectives.
So the question is, can I work while I'm in the program? Yes, that is correct. Our courses, the majority of them, are handled through either recorded lectures or face-to-face lectures that will be recorded. So typically you would want to take one, maximum 2 courses while you're in a master's program. Workload will dictate that so that you've got enough time to do both and do both well. But most of our students, especially our distant students, are working while they're part of the program. Are there scholarships available? There are some. At the Olathe campus in particular, there's some options for scholarship in regards to students taking courses through us here. Not sure that there is support, financial support, if you're a distant student. In fact, I know that there's not in regards to the programs. But at the Olathe facility, we do, being really building this program, we're offering some incentives in a sense with coming to join us here as we get K-State Olathe off the ground. So there are scholarships available. Okay? All right. Well, like I said before, contact Dr. Kramer or myself. We're happy to answer any questions if you'd like to schedule a visit, either to the Manhattan campus or to the Olathe campus. We're very happy to accommodate. We appreciate you taking time today to listen to this, and hope that you might find a fit with our programs and what you want to accomplish in regards to your career. Thank you very much.